Okay, I know the post for this question included part for Simpson's rule, but this video is only going to answer part 1 for trapezoidal rule. Here's the original function, which is this black graph right here. And we're going to use the trapezoidal rule to kind of envision what or approximate the area under the curve from 1 to 6. There's what the rectangles or the partitions look like from 1 to 6 if there's 22 rectangles. And this expression right here is an upper bound for the area, for the error in the area. And so when there's only 22 partitions, that's the upper bound for the error right there. So we want to find out what value of n will make this error less than or equal to 0.01. So we're going to solve this inequality right here. Question is, why do I have a 7/2 here? Well, I found f double prime using the power rule. I reduced to this, which that's a downward opening parabola. And this is actually a picture of that downward opening parabola. And we're trying to find in here the maximum value of the absolute value of f double prime on the interval from 1 to 6. That's what this number is right here. The maximum value of the second derivative on the interval from 1 to 6. Well, this downward opening parabola has a vertex at 3.575. So that's the maximum value of the second derivative on the interval from 1 to 6, because this 3.5 happens to be in the interval from 1 to 6. Now, for other functions, you got to use a different technique to find out where the maximum occurs. But in this case, we've got a downward opening parabola, so the maximum occurs at the vertex. So this number really here is really a 75. So there is the inequality that we want to solve right there for n, where b is 6, a is 1. So we'll go to board 2 and take a look. There was the inequality we wanted to solve. I replaced b minus a with a 5. There's 5 cubed. There's the absolute value of f double prime of 7/2, which is 75 over 12. Now what I did is divide both sides by 0.01, which means I don't have to reverse this arrow because 0.01 is positive. And I also multiplied by n squared, which is also positive. So that results in this. So n squared has to be greater than this number right here, which I labeled with a Q for no particular reason. That's 78,125. So n squared has to be greater than that number. So n has to be greater than that number, which is 279.5. So I need an integer. If I use 279, the error will still be a little greater than 0.01, so I have to use 280. That's how many partitions I need for the trapezoidal rule to have an error less than 0.01 from the true value of the integral. And here I set n equal to 280. There's the upper bound, 0.0099, which is less than 0.01. Here's the value that's generated by the trapezoidal rule. We won't go into how that was calculated on this Desmos graph. And here's the actual value of the integral, 465. So the difference between these two, 0.0066, which is less than 0.01. Now, if you go into Desmos and change this to 279, that error will be a little bit bigger than 0.01. So you got to go to 280. I'll include a link to the Desmos graph that has all this in it. You can take a look. There you go. Hope that helped. If you have any, by the way, Simpson's rule is very similar. You just need to look up the formula but it's kind of almost identical technique. There you go. Hope that helped. If you have any questions, post a comment.